So just now we have discussed about the fundamental rule about asynchronous counter. What is the fundamental rule? In a register, we have a collection of flip-flops. So in this asynchronous counters, we are going to give a different pulse for the different flip-flops. Means the pulse is not same for all the flip-flops in a counter. So this is basic fundamental rule. Asynchronous counter refers to states that does not have a fixed time. Does not have a fixed time. Why does not have a fixed time? The clock is different, right? Yes or no? The clock is different for every pulse. Different does not have a fixed time. Relationship does not have a fixed time relationship with each other. Fixed time relationship with each other because we are not using similar clock pulse. Because we are not using similar clock pulse. In asynchronous counter flip-flops, does not have a common clock pulse. Does not have a common clock pulse. You know this. Does not have a common clock pulse. So their states. So their states does not change exactly at same time. Exactly at same time because time is different. One clock to another flip-flop, time is different. But don't expect the outcome in the same time from the different states because we are giving some flip-flop for some duration and other flip-flop for some other duration. Don't expect outcome for the same states in the same time. As we are not giving similar clock pulse, each flip-flop does not give out same time. As we are not giving similar clock pulse, each flip-flop does not give out same time. Same time, same out. Does not give out. Out means output, same time. If a one flip-flop is giving output, if one flip-flop is giving output, but other may not in the same time because of different clock pulse. Other flip-flop may not because different clock pulse. In this asynchronous counter, first important point, note down carefully. In this asynchronous counter, first flip-flop has clock. In this synchronous counter, only the first flip-flop has clock. Output of each flip-flop will act as clock to the next flip-flop in the counter. Clock to the next flip-flop in the counter. Just see this. In this asynchronous counter, any asynchronous counter, you are going to design any asynchronous counter. If you want to design, only we are going to give clock to the first flip-flop of the counter. Please remember, only we are going to provide a clock to the first flip-flop of the counter. Then what about the next flip-flop or next connected flip-flop? The next connected flip-flop, the clock is output of its previous flip-flops. Because we don't know what clock duration is going to be provided by this flip-flop. We don't know what it is going to get. We don't know this. But you know this clock. Because this clock you are giving. The clock is active or not. Are you clear? Initially you want to activate, you should give high voltage. Nothing but 1. Yes or no? So circuit will be enabled. When circuit will be enabled, this will generate something. The generated output is going to giving to the next flip-flop as a clock. Okay, that is positive. This circuit will be active. This flip-flop will be active. If it is negative, this flip-flop will be idle. Understand? That is why different, in this case, you can understand different flip-flop having different clocks. Clear? Clear? This is the structure you should understand for implementation of your asynchronous counters. Okay? The best example for these asynchronous counters are ripple counter. Application of this asynchronous counters are ripple counter. We are going to discuss next immediately ripple counter. Before those 2 points you write. Any counter, these 3 points are very important for designing of the counters. Maybe you are expecting more theory today, we are right, but these are designing procedures. If you know this, implementation is very easy. Any counter, if we want to design any counter, we should use JK flip-flop or T flip-flop. Any counter, if we want to design, we should use any asynchronous counter. Please make a note. Any asynchronous counter, if we want to design, we should use JK flip-flop or T flip-flop. Either JK flip-flop or T flip. Means when you are going to design a counter, counter is a collection of flip-flops. If you want to design a asynchronous counter, you should use JK flip-flop or T flip-flop. Because why? Why? Because toggle. Yes, good. Because these flip-flops are having toggle condition. These flip-flops are having toggle condition. Why toggle is required? Now this flip-flop, when it is going to activate, when it will be activated, when the clock will be positive, it will be activated. If it is going to generate negative, then this is not going to activate. If it is not going to activate, 0. But you should toggle it. Then you toggle, the next one will be activate. Understand? So that is why you should use either JK or T flip-flop. Now final statement for this asynchronous counter. In this asynchronous counter, the total states are 2 per n. The total states are 2 power n, and each state frequency. This is very important formula for everywhere you need to calculate. In gate examinations, competitive examinations, they will ask, they will give some inputs, they will ask each state frequency. They will ask each state frequency of the asynchronous counter. For this is the input, this is the output, they will ask. So please try to remember each state frequency equals to f by 2 power n. What is f? This is a total frequency. F is a total frequency by 2 power n. What is the 2 power n? 2 power n. N is a total states are 2 power n. N is what? Means, for example, 4-bit counter I want to design. So how many flip-flops you want? Don't expect they directly they will give 4. They will tell you design a 4-bit counter. Yes or no? For that, what is a the frequency is 2. 4-bit counter, you design 4-bit counter. For each bit, the frequency, the pulse rate is a 2. They will tell, not frequency. They will tell pulse rate is 2. That is what a frequency. So calculate each state of frequency. They will ask indirectly. Don't think they will give F is this, N is this. Okay. So you should understand the question. So the final they will ask each state frequency for asynchronous counters are f by 2 power n. Clear?